All right, here we go again. So welcome back to another video, guys. Today we're going to be looking at a few examples that I think will help you out when you're trying to model with your linear functions. So let's look at some of what we've got today. By the way, for the last problem, I am going to be using a TI-84 to help me out. But a lot of these we can do by hand without a calculator. So let's look at number one. So we're going to use this graph of this data here to write an equation of the line and interpret the slope. Okay, so I think it looks like we've got 2 points here. So what I would recommend is every time you have 2 points or you have a graph and you're trying to find an equation, what I would do is try to find your slope first. So remember that we can find our slope using the slope formula, which is m equals y2 minus y1 over x2 minus x1. So we need 2 points, and right here in our data we are given 2 points. So let's say that this first point over here to the left is going to be my 1, so we'll say that's x1, y1. And this other one over here will be my x2, y2. And that's a little bit hard to write in there, but y'all know what I'm saying. That's a 2. It's supposed to be. Okay. That looks terrible, but you know what I'm saying. All right, so let's solve this. So my y2 is going to be 51. My y1 is 50. Divided by my x2. And you know what? I need to move this over so y'all can see this. All right, x2 is 10, and my x1 is 0. All right, let's solve that. 51 minus 50 is 1, and 10 minus 0 is 10. So our slope, it looks like, is 1/10. Now, we can write an equation for this function using the point-slope formula, point-slope form of a line. And that is just y minus y1 equals m times x minus x1. So we can use that same 0.1 that we used to find slope for our formula here. So we'll have y minus y1 was 50 equals, my slope is 1/10, and then x minus 0 in this case, so it's just going to be x. So we don't even need the parentheses for this. So there we go. Now if we wanted this to be in point-slope formula, we could just add the 50 to, or not point-slope, but y-intercept. Yeah, is that what he said? Slope-intercept form. If I want this in slope-intercept form, we can just add the 50 to the right, so we'll have y equals 1/10 x. And hopefully y'all can see that. I think you can. 1/10 x plus 50. 1/10 x plus 50. So this is asking us to interpret the slope. We already did the equation of the line. That right there is the equation for the line. And then it says also to interpret the slope. So what is the slope telling us? Well, we can see that y is measuring cost in dollars, and number of text messages sent is measured on the x-axis. So we can see as we send more text messages, our cost increases. And we can see that the cost is increasing by 1/10. I guess this is in dollars, yep. So it's increasing by 1/10 of a dollar per text. So that's what our slope is telling us. So 1/10 of a dollar per text. 1/10 of a dollar per text. That's what it's measuring. So that would be 10 cents per text. So that's what that slope is telling us in this case. All right, let's scroll down and look at something a little bit different. Okay, so we've got a little word problem here. The cost of parking in a parking garage in Chicago is represented by this equation. We're going to underline that because that's going to be important. Y is the total cost in dollars, and X is the time, I guess, that you're parked in the parking garage. The table below shows the total cost to park in a parking garage in Denver. So this is Denver. And that equation was Chicago. Which city's parking garage charges more per hour, and by how much more? Okay, so to be able to answer that question, we're going to have to get an equation for Denver so that we can compare Denver and Chicago. We already know what the equation is for Chicago, so let's try to solve, we'll try to get an equation for Denver. Okay, so I think we can do this using kind of the same method we did before. We have 2 points. In fact, we have 4 points in our data table below. So let's just pick 2 of them. And first, I guess we want to make sure this is linear. So we see that our change in x is by 1 here. So that change in x is by 1. And the change in y is, it looks like 8. And that needs to be consistent. So every time we go up 1, let's see if we go up 8 down here. 51 to 59, so it's also increasing by 8. So it looks like we have a consistent graph. This increases by 1 again. That increases by 8. So yeah, that's consistent. It's increasing linearly, so we can solve this problem. Okay, to solve the problem, let's go ahead and figure out our slope. So let's do m equals, let's do y1, you know the formula, y1 minus y2, or y2 minus y1 over x2 minus x1. So let's say that this up here will be my x1 and my x2, and we'll say this is our y1 and our y2. It doesn't matter which points you pick. So just pick whichever ones you want to be whatever. Okay, x2 minus x1, so that's 3 minus 2. Oh, we're supposed to put y on top. All right, so y2 minus y1 is 51 minus 43 divided by, let's see, 3 minus 2, right? x2 minus x1. So we're going to get 51 minus 43 is 8, and 3 minus 2 is 1. So it looks like our slope is going to be equal to 8. So now we can write our equation. So remember, our equation is y minus y1. Let's go ahead and use the y1 we have, so 43, equals our slope, which is 8, times x minus x1, which in this case was 2. Now, we want to get this in slope-intercept form so that we can compare it to Chicago. So let's go ahead and distribute that 8. So we'll have 8x minus 16. And then let's go ahead and add the 43 over. Okay, so we'll have y equals 8x, and then we'll have negative 16 plus 43. And so we'll get 27. All right, so now we're in slope-intercept form. So let's erase some of this. And really, we can erase this as well. Okay. Let's see if we can bring this right up here. All right, so that's going to be Denver's equation, and then Chicago is going to be, let's put that in blue, y equals 15x. We're just getting that from the word problem right up here. 15x plus 20. Oops, that's not supposed to be a 26. That's supposed to be a 20. All right, now the question again is, which city's parking garage charges more per hour, and by how much more? So the more per hour is going to be, remember x is our hours, so we're looking right here for how much per hour we're getting charged. So in Denver, we're getting charged $8 per hour, and in Chicago, we're getting charged $15 per hour. So which city's parking garage charges more? Obviously, $15 per hour is more than $8 per hour. So Chicago wins the most expensive one. And by how much more? Well, the difference in 15 and 8 would just be 7, right? So Chicago is $7 more expensive. Now the next question here asks us, after how many hours would both cities cost the same? How many hours would they both cost the same? Well, if they're going to cost the same, then we would want to set the equations equal to each other if we want them to cost the same. So to do that, we're just going to take Denver's equation, which is 8x plus 27, and we're going to set it equal to Chicago, which is 15x plus 20. And then we'll solve. So let's subtract the 8x to the right. So we'll get 7x over here. All right. And then let's subtract 20 to the left. So we'll get 27 minus 20 is 7. So we have 7 equals 7x. To solve for x, let's divide by 7. So we'll have x over here, and then 7 divided by 7 is just 1. So it looks like after just 1 hour, the prices for both garages will be the same. So we answered our question there. All right. One last thing we want to look at in our video today is how to use the linear regression feature on our graphing calculator to find an equation, a line of best fit for the data. So let's do number 5, and actually we're just going to do number 5 in this video, but if you want to try number 6 for practice, you can do that. So for number 5, what we're going to do on our calculator is we are going to hit stat, which is a little button right here. We're going to hit stat on our calculator, and then a little table comes up, and we are going to hit edit. Okay, and this table comes up, and we're able to enter in our data. So in the L1 table, I'm going to put in all of my x coordinates for each point. And we want them to line up with all the y coordinates, so we need to keep track. So let's number them. Let's say this is 1, 2, 3, let's say 4 and 5. Okay? So our x coordinates for 1, 2, 3, 4, and 5. X coordinates for number 1 is 1. So I'm just going to put a 1 in and press enter, and it will store it into my table. And then I'm going to, for number 2, the x coordinate is 2, so I'll press enter. 3 for 3. For number 4, our x coordinate is 5. And for 5, our x coordinate is 5. So I get all of my x coordinates loaded in. And then we'll do the same for the y coordinates. So I'm going to go over to L2, my table 2, and I'm going to put in all the y coordinates for 1, 2, 3, 4, and 5. So for number 1, my y coordinate is 5. 2 is 2. 3 is 1. 4 is 5. And 5 is 2. So I get all of my data into my data table, and then we're able to press second. Let me make sure I'm doing it right. Okay, you're not going to press second. You just, once you get the data into your table, once you get all the data into your table, you just press stat. Okay, press stat right here on your calculator, and data, a little table will come up. What you want to choose is calculation, so you'll go over to the calculations options, and then you'll go down to where it says linear regression, AX plus B, and press enter. So it'll come up with some options, and you just press enter, or you go all the way down to calculate, I guess, and press enter again, and you'll get this information. So what is showing on my screen is y equals ax plus b, so that's slope-intercept form, and then it tells me what a and b are in the table. So we can see from this that our equation is going to be y equals negative 0.078 x, and then my b is 3.25. And you can see that information here on my table. One more important thing to look at is what this r value is. R in this case is 0.0747. Now I will say the closer that number is to 1, the this fits an actual linear system. This number is actually very far away from 1. So if we're really close, like if you did number 6, you would get something like 0.99 or 0.98. For this one, our R value is so low that we would say that this system, or this function, does not represent a linear function, at least not very well. And we can see that by the data in number 5. Our dots are kind of all over the place. They don't really form a line. If you look at 6, 6 forms a line a whole lot better. So if you want to try that one, you can. You should get an R value that's a lot closer. But anyway, if we did try to force number 5 to be a linear function, that is as best as we could get using the linear regression feature on our calculator. Anyway, I hope you enjoyed this video. If you have any questions, let me know, and I'll see you all next time.